Hey everyone, so I got directions for your summative. First of all, this is optional. This is for people looking to improve their grade in the class. Anyone interested in doing that, I highly recommend you do the summative. You are allowed to use your mole island periodic table and a calculator, and you are not allowed to use notes, friends, internet, things like that. This is a test, even though you're at home. I'm trusting you to be honest. So first thing you need to download and read the directions, and then the report template. So this is just like the review lab. You'll have a direction page and then the actual report template that you turn in. And you're obviously watching this video, so you found the video part. You will either handwrite your report or type it up and then submit your report into there's an assignment that says Stoichiometry Summative Lab. That's where you submit your template. Email me if you have questions with that. So here's the direction page. I'm going to go through the lab for you guys in the procedure, but this is where you'll find the purpose, and then obviously you'll have to summarize your procedure, and then some tips for your conclusion, things like that. One thing I'd like to point out is the first chemical that I'm going to be using is called copper 2 chloride dihydrate, and it has a formula like this. We've never seen anything like that before. There is a tip in the procedure about finding the molar mass, but I just want to talk about that for 1 second. So a hydrate is a solid that absorbs water from the air. So picture something super absorbent, like kitty litter or anything of that variety. So the water molecules that are absorbed by the solid impact the molar mass. So for us, we're using copper 2 chloride dihydrate. And in chemistry, the dot, let me just grab my little pointer. This guy right there, that means there are 2 water molecules absorbed for every 1 molecule of this. I know a dot in math class means multiply. It does not mean multiply here. It just means there's 2 extra water molecules added. So here's how we find the molar mass. First, we find the molar mass of CuCl2, so 1 copper plus 2 times the mass of chlorine. And then we add water. Water has a molar mass of 18.02, and there are 2 water molecules. So notice that is being added even though there's a dot right there. Dot is not multiplied in this class. So that's how we got the molar mass of 170.48 grams per mole. Here's the part you need to care about. You will use this molar mass when you do your BCA table to go from grams of this chemical. So when we go from grams of the copper chloride dihydrate chemical to moles to get our before box in the BCA table. We will not use this in our we will not use the water molecules in the balanced equation, because what you're going to do in this lab, or you're going to watch me do, as soon as I measure out this chemical, I'm going to dissolve it in water. And what happens? Those H2Os just join the water, and then we don't care about it anymore. So really, here's what you care about. When you go from grams to moles for your BCA table with the starting mass, you're going to use this molar mass instead of the normal molar mass of just copper with chlorine, and then pretty much the rest of the lab you will ignore the fact that it started with water. Here is your lab report, so you will fill in everything just like you did for the review. There's some guidance for your calculations. So more calculations here, and then conclusion. The direction page had some guidance for you on the conclusion if you forgot. And notice it says can be bullet points, but they need to be complete sentence bullet points for your CER. And don't forget, I'm looking for 2 evidence, 2 reasonings. All right, step number 1 says weigh out 2 grams of copper 2 chloride dihydrate. So it says copper 2 chloride, but look at, it says copper 2 chloride dot 2H2O. There's the formula weight, which is the same as molar mass. So I'm going to measure out 2 grams of that guy in 150 milliliter flask, or beaker, excuse me. So this chemical it reminds me almost of like wet sand. That's like what a hydrate is. I'll try to show you. See? So there's that chemical. Let's see what we got rolling here. Oops, except I didn't zero out my beaker. Let's try that again with this one. Almost there. so on my data table, I have highlighted where we're going to put this mass, and we have 1.93 grams. Next, it says to use a graduated cylinder to measure out 25 mils of distilled water. So part of our materials, distilled water. I know that's ethanol, ignore that, it's just DI water, I swear. Filled it myself. And I have a graduated cylinder that I measured out 25 milliliters, roughly. And I'm gonna pour. And it says stir until the solid dissolves. So I got my glass stir rod. And while I'm stirring, it says to record your observations of what this dissolved chemical now looks like. So underneath the data table, there's room for you to write observations. There you go. That's where you're going to put your observations. All right, next says measure about 0.1 grams of aluminum metal and record actual mass you use. And you're also going to do observations. So there's my aluminum pieces. You'll put observations of what it looks like. And I'm going to measure out about 0.1 grams. So I have a weigh boat. I'm going to re-zero my balance. And I need about 0.1 grams. Closer. Got one more in me. Ooh, that'll, we'll do, I'd rather have a little more, I think. Oh, right on the money. Look at us go. All right, so we got 0.10 grams of aluminum. So put that in your data table. All right, it says rip the aluminum into very small pieces and add it to the copper 2 chloride solution. Solution means we had already dissolved it. I'm gonna use my stir to kind of poke those guys down there. I'm hearing some fizzing. I don't know if you can hear that in the video. And hopefully you can see clear enough what's happening. Interesting. Swirl the solution gently and let sit for 5 minutes. And then record observations. So I'm going to let this guy sit for 5 minutes and kind of swirl in between. All right, 5 minutes later, I've been swirling here on and off. I'm gonna try to tilt this so you can see the bottom. Wish my camera were a little clearer. Or maybe this way is better. Let's go to the light. Hopefully you can see what's on the bottom, the color of the liquid. When I'm touching it, it does feel warmer, so that's a good observation to jot down too. I understand you can't touch it, so I'll let you know it feels warm to the touch. So add those to your observations. So now that our reaction between the copper 2 chloride and the aluminum is complete, step 6 says to get a piece of filter paper and record the mass of it. So I'm going to zero out my balance. Put the filter paper. Feel free to record that in your data table. All right, filter the mixture through the filter paper. So if you look, I have a ring stand, I have the ring, a clamp, I have the clay triangle, a funnel, and an extra beaker. And now I'm gonna fold my filter paper. And this is the same piece that we just masked. I'm going to add a little water to keep it from popping up. And we're going to filter. Notice there's lots of solid chunkage in there, and I can assure you, I'm not going to make you watch the entire process, but I will use the extra water in the squirt bottle to make sure that this beaker is clean when we're done filtering. So all those solids will be put through the funnel, probably with some extra water, which won't make a difference to our results. I'll check back when this is done. Okay, I think we're done filtering. About 30 minutes later. I was playing with Phoebe. Say hi, Phoebe. Okay, so this was the beaker that had our products from the reaction in, and I tried to rinse it with lots of DI water. In fact, I can even prove to you. Remember, we originally dissolved in 15 milliliters, and look, I used almost 75 milliliters, roughly. Again, beakers we don't usually measure with, but almost 75 total milliliters to get this whole thing transferred. So I used lots of extra water. So you can see when we mixed the copper 2 chloride with the aluminum, the reaction was to make aluminum chloride and copper. So here's my copper, and there's aluminum chloride. What's interesting to me is aluminum chloride is not usually blue. It's actually clear when it's dissolved. So we have aqueous aluminum chloride down there, and we have copper. So what tells me that blue color has to be coming from something else. Well, we know that very rarely do reactions work perfectly with the hot dog and hot dog bun situation where they both run out, meaning the aluminum that we mixed is not likely to run out at the same time as the copper 2 chloride, so those two reactants. So hopefully using your observations, you're able to see maybe what is excess in terms of our reactant. So now step 8 says to wash the copper with distilled water to remove any dissolved aluminum chloride. So if aluminum chloride is dissolved down here, and same maybe with excess reactant, maybe up here, excess, who knows, you guys will figure that out. But I just care about the copper right now. So I don't want any of my other product to be stuck to my copper particles or any excess or anything like that. So I'm going to just rinse this guy with good squirts of DI water and hope that it's basically running through one more time, and any stragglers that I don't want in my filter paper are going to go through the funnel. All right, so we finished the wash. It's maybe one more drip. I'll talk through it though. Finish the wash, and then that's the filtrate down there. Notice that blue color. That should help you with the calculation or the analysis question number 2. About having the leftovers be blue in color, but I can discard that because we don't care. This is aluminum chloride for sure, the product aluminum chloride, and maybe something else, we'll see, but I don't care about this for this particular lab, so I'm actually going to wash it down the drain safely with extra water, and I'll do that after the videos. And really all we care about is that copper product up there. So it says to let the filter paper dry overnight, right? I could take this out right now and get a mass, but that would not just be the mass of copper. It would be the copper plus filter paper, plus clearly the filter paper and the copper are still wet. So I'm gonna let that dry overnight by putting the filter paper on a paper towel with all partners' names is what the direction said. So I did Butler and no lab partner. So we'll take, here's my funnel. I'm going to just gently take the filter paper out, and I'm actually going to try to open it up so it dries a little faster for me, but chances are this will take overnight, so I'm going to have to wait until tomorrow, but I'll fan that guy out. There's all our copper, but you can see it's clearly very wet. My fingers are wet. There's our copper. There's Phoebe Buffet. See you tomorrow to get the mass. All right, guys, I waited overnight, and we now have the dried copper on the filter paper. And we want to see how much copper we actually made. So I'm not going to scrape it off. That would, I'd probably leave some behind. So what I'm going to do is I'm going to mask the copper that we actually made with the filter paper, and I get 1.39 grams, so that's how much copper we actually made, but it's also with the filter paper. So to get my actual, don't forget to get rid of that filter paper in your calculation section. So now it's up to you to do this lab report. Make sure, just a couple reminders, you're using the direction page as well. It has the purpose, it has a procedure for you to summarize. Don't forget diagram and materials, that's 2 separate points. So you sketch all of the materials and then label them. If you need more room for the drawings or the procedure, or really any part of this lab, just use a separate sheet of paper, that's fine. And I know some of you don't have printers, so your whole thing's going to be on separate paper. That is fine. You got your data from the video and your observations. For your balanced equation, please don't forget we don't need water. So it should just be copper 2 chloride, CuCl2 plus aluminum, and then it tells you the products. Don't forget to balance as well, and a couple questions for you to answer there. Figure out your theoretical yield. That sounds like stoichiometry to me, so you know how much aluminum we started with, you know how much copper 2 chloride dihydrate we started with, so you can get those guys into moles and do your BCA table, find out how much copper we should have made in theory. There's a follow-up question as well, and then actual yield, that's pretty simple. You saw how much we actually made, but it's stuck to filter paper, so a simple calculation there, and then percent yield of copper. And then for your CER, again, claim 2 pieces of evidence, 2 reasonings with kind of an error section in the reasoning. I would look at the procedure page with all the directions to help you out with that, with the CER. Good luck, guys. Submit this when you are finished.